I want to introduce myself really quick, just a couple of things I've done, because you might be saying, what the heck does this guy from research know about building software and about real engineering? Okay, and the answer is, well, not a lot, but I have learned a few things over the few years. One of them is I have a thing called Detours. Anyone ever heard of Detours? Okay, so I am Mr. Detours. I am the entire Detours product team. I am the PM, I am the developer, I am the support team. Every single support request that comes in for Detours, I handle it. And it's used by nearly every Microsoft product team. We license it to over 100 external companies. I think we're up to about $2 million in revenue on external Detours licenses. Why is this relevant? I've had to maintain this thing for 15 years, okay? And so I've learned a lot about how and maintain it and share it and push out updates to customers and to Microsoft things. And so I've learned a lot about how to build a piece of code that is a component that can be reused by many, many teams, and that people fall, in the words of Rico Mariani, into the pit of success with it, okay? Another thing I've done is Experiment 19. This was, in retrospect, the prototype for Phone 8, okay? We showed for the first time that it was not only could you, but it was the right thing to do to put NT on a phone and put the core CLR on with it and put Silverlight on with it, and showed that not only did it actually work well, it worked better than the existing code bases that we were doing, okay? And so I've done a lot of refactoring and rebuilding things and taking your wonderful code and making it do things that it wasn't supposed to do before, okay? The other thing that's relevant here is Drawbridge. So Drawbridge is a really lightweight alternative. Anybody heard of Drawbridge? Oh, good. All right. A lightweight alternative to hypervisor-based VMs. And the core thing in terms of relevance to this audience is we refactored Windows into a library OS. Okay? And our smallest library OS was, I think, on a working set of about 16 megabytes. The current ones are larger than that. But I've got a lot of experience of slicing and dicing pieces of Windows and putting them together in new ways. I've done a few other things. I did the prototype for Windows Media Player as an intern. I did this system called Big, oh, good heavens, over 10 years ago. We invented cloud computing. We just couldn't figure out how to get Microsoft to ship it. And I did this thing called Singularity, which was an entirely new operating system written in managed code. Fear, okay, all right. And my work strategy is I know that I'm not the smartest person in this room. In fact, I'll bet every single one of you in this room is smarter than me. But I know how to find people and convince them that they want to work with me and work together so that I can learn from them. All right, so what is an engineering system? That's what we're here to talk about today. Well, an engineering system it's a set of end-to-end, the tools and the processes for turning source code into deployed products and services, okay? So in some cases, it actually includes the people. It's how the people come together to produce software. But I kind of like to think of it from the perspective of, I have a line of code. What do I do with that line of code in order to get it into a product and to maintain it across the life cycle of a product? What do I do, in fact, to get it into multiple products? So how do I submit it? How do I build it, test it, flight it, deploy it, service it, refactor it, include it in another product other than the one that it was originally intended for? Understand how it's actually used in practice, and discover who depends on it, okay? All of those things are about the engineering system. And I want you to get that whole spectrum into your mind, because it's actually the whole spectrum that we care about. In fact, as kind of architect on this thing, my job is to think about, make sure everybody remembers the entire spectrum of the engineering system, and not just the three or four pieces that we're building right now. So what is the goal of all engineering systems? It's to support the business model, okay, which is to take source code and turn it into money. Okay, that's what a business model does. And also to make it easier for you as engineers to do your job so that we can make money from the source code that you produce. Okay, so how to make it so you can produce customer value. That is the end goal of the engineering system. Now, the engineering system that we're trying to produce at Microsoft, One Engineering System, what it is about is an initiative to create an engineering system that enables us to reuse and share code across products. If you don't take anything else out of this meeting, I want you to walk away with one thought. You come in and you say, oh, I build Windows, or I build Xbox, or I build phone. Okay? My code is phone or Xbox or Windows. I want you to go away with the, I produce code that is used in many products and it is valuable, and I try to make sure that the people who are running the business and trying to produce products that are going to generate cash that are going to keep me employed can use it in as many ways as they possibly can. Okay? It's the one Microsoft message, but translate it down to engineering. Okay? We want to produce an engineering system that fosters collaboration, removes barriers, reduces friction to you doing your job and producing value, and that is used across all of Microsoft. Because even if you're an IC in Windows and maybe you've mastered the tribal knowledge, I like to use Neil Christensen's group. So you're in the NTFS team and you've mastered the tribal knowledge of how I build NTFS and make changes to it and how I get that onto my machine to test it and things. That tribal knowledge can't be shared across for anyone else that comes and joins the group. And whatever best practices you develop, because of our engineering systems, we want those best practices to be able to be transferred as rapidly as possible to other places in the company. Okay? So reducing that kind of friction as much as possible. That's what we're after. So I've divided the rest of the talk in kind of 3 sections. I'm going to talk about why we actually need a new engineering system. And then I'm going to talk about what Apex, which is the first incarnation of a new engineering system, might look like. And I'm going to also do a call to action. I've done my first one already. Think about how you change your mindset of what it is I produce. I produce code that goes into many products. Okay. All right. So this is a cautionary tale. All right. I want everyone in the room has to promise me one thing. Okay. If you can't make this promise, you should get up and leave right now. And that is that when I get done with the next 5 slides, you will not quit. Okay? So everyone raise their hand. Okay, look at your neighbors. If your neighbor hasn't raised his hand, tell him he's got to leave the room. Okay? Dave didn't raise his hand. Well, Dave's getting nearer to retirement. He might retire a little bit earlier. Okay? Okay. All right. Okay, so we're all committed. We're in this together. We're gonna embrace these 4 slides, and we're going to embrace the opportunities that they represent and not quit, right? All right. I warned you. Okay, so this, by the way, all the data in the next 4 slides is all publicly available. It all came from IDC and the web, and I have just curated it in order to tell a story. Okay. So the first slide is the first year of Windows Phone 7 versus the first year of Android versus the first year of iPhone, and it is cumulative units sold up to that point. So over 4, well, I guess it ends in the 5th quarter, but 1 year. All right, and you look at it and you say, hey, we did pretty good. Okay, I am incredibly awed at the phone team and what they've managed to accomplish in the last 4 years. And we'll talk about this a little bit more. But hey, they did great. They actually had a great number of shipments. The product was embraced. Okay. In fact, it looked so positive at the end of the first year that both Gartner and IDC were predicting that by the end of next year, we would have market share equal to iPhone. Okay. Now, it doesn't quite look equal on here because I've now changed. And for the rest of the graphs, instead, what I'm showing is the cumulative number of units sold in a 2-year period, because that's basically the life cycle of a phone. And so that by adding up the numbers sold in the last 8 quarters, the last 2 years, that tells us effectively how many machines are out there, which tells you how big your installed base is for and your market for applications. And that's what this is all about, right? We create ecosystems where devices come together with software to create value for customers. Okay, but anyway, everybody predicted, hey, Phone 7 is a fantastic product, and it's going to go great places. Okay, And of course, Android was going to go even farther because it got ahead of us. All right. Well, add 2 years. This is where you start to panic. This is where everybody in the room gets a little nervous, and you should, okay? Because it didn't happen, okay? Now, I want to point out a couple of things. One of them is the people doing the predictions were not completely insane and completely irrational. They actually nailed pretty closely what the iPhone market share would look like, okay? What they didn't predict well is what happened to us and what happened to Google, or to Android, okay? And what happened to us is, well, we didn't go very far. We haven't gone our market penetration has not been fantastic. And Android has actually exceeded everyone's predictions, okay? Why is this? Okay, we had a great product. What they failed to recognize, what Gartner failed to recognize, and what IDC failed to recognize, which is funny because they know this stuff very well, is that software and operating systems work in what's called a network economy, or positive network economy, okay? Which is, think about a telephone. The easiest way I describe it is, think about a telephone. If you're the only person in the world that owns a telephone, it's not much value to you. But as soon as your friends have a telephone, then the value of your telephone just went up a whole bunch. Not because you bought anything new, but because someone else bought a telephone. And so there's a connectedness that comes in. And if their friends buy a telephone and you're all connected, then you get even more and more value, okay? Software works the exact same way, and particularly platforms work the same way, because you've all heard this, I'm sure. I'm just repeating what you already know. But because the more of a platform that exists, the more Android units there are out there, the bigger the market is for the application developer. The more they target that platform, the more applications they produce, which in turn creates more incentive for the customers to buy an Android phone.
So they didn't think this would happen with a software telephone?
Yeah, so the question was, these guys didn't think this would happen with a software telephone. I would just say everybody really wanted Microsoft to win, okay? I think it was hopeful thinking, okay? And you might ask, well, how come they haven't decimated iPhone? And, well, there is a niche there. They've got some first mover leverage, etc. Okay. All right, so I'm now going to focus on just up through the end of 2013. Oh, I did read that. Okay. And let's look through this in a little more detail. And let's talk about what all this means. Okay, so the first thing, I've kind of got the cadence of Windows Mobile and then Windows Phone, just to kind of give some dates and put things in perspectives. Now, let's talk about iPhone for a minute. Okay. You might ask yourself, why did we not ship iPhone? Why did we lose there? Why did they win? Okay. Is it because we didn't know about capacitive touch and we didn't know when it was going to land on a phone? It wasn't, okay? We knew all the technologies that are in iPhone, pretty much all of the interface, all the capabilities. We actually had most of it in our labs running, okay? What happened was a leadership failure, okay? The people running the phone business unit did not recognize that we had... I don't have the market numbers in here, but mobile had really great market share of the existing smartphone market at that point. And what failed to happen was to recognize that we were ripe for being knocked off of our perch, that there were fundamental changes in the technology, one in terms of capacitive touch and what you could do around a UX based on capacitive touch. Another one was around the fact that there was better user interfaces for a phone device than a start button, okay? That's the one place where we shouldn't have a start button, okay? And also a failure to recognize the value of enabling third parties to target many devices very rapidly, and the thing there. And I think the other one was a failure to recognize how important it was that we get to a unified code base, okay? So there was this leadership failure, okay? We just failed to see what happened. And it persisted for a while. For the first year, roughly, of iPhone, I remember going to these meetings, and, you know, it was pre-Andy Lee. I can't remember Andy Lees. I can't remember who it was running the business at the time. But even after he got fired, he was still in denial that iPhone was a huge thing and a huge innovation. Okay? And what it shows is we just have to be aggressive. We have to keep moving forward and keep looking. Now, the other thing I want to talk about is I was actually in the phone space. I was doing the precursor to Experiment 19 at the time. And we were going out and meeting with carriers and hardware chipset vendors for phones and with hardware OEMs for phones. And in this time period here, the latter half of 2007, the first half of 2008, iPhone was hot. Okay? And these people were desperate. We'd walk into a room and we'd say, hey, we're from Microsoft. We want to talk to you about phones. And they would basically said, we will give you our children if you will give us something we can compete against iPhone with. Okay? Particularly the other carriers, because it was 4 years before Apple allowed went beyond a single carrier in each of their markets. And so the carriers were, anything. Give us anything. We will ship it. Just give us something to compete. And we came up empty, okay? Now, these other guys, on the other hand, didn't, okay? And I want to point out a couple of things here. The first one is the Android Play, it was straight out of our playbook, okay? They didn't do anything that we didn't know how to do, okay? For example, we know that the way you compete against Apple is you go for breadth. You allow as many hardware vendors as possible and as many carriers as possible and everybody else to build a phone based on your platform or to build a PC on your platform, right? If you look at the Android Play, it was exactly the PC Play all over again. You create standards so that you can reuse the software as easily as possible across a wide number of machines. You get the software out there, you create a platform that the applications go on, and you sell it to everybody and their dog for whatever price they're willing to pay, including give it away if you have to, so that you get network effect economies. Okay? There was nothing from that perspective they did that was anything different than us. They just managed to do it faster than we did. Okay? The other thing I want to point out here is look at the release cadence. They were shipping almost once a quarter, okay? And the fact that they shipped 2 years before we did, we didn't ship till almost 4 years after the iPhone came out. The fact that they could ship on a quarterly cadence and we couldn't. The fact that we didn't have a converged operating system until almost 6 years after iPhone and 4 years after Android. That was not a leadership failure, okay? In terms of a business thought leadership failure. That was an engineering system failure. Our engineering systems created too much friction. It was too hard for us to reuse code. It was too hard for us to repurpose and retarget code. And it was too hard for us to ship rapid releases. And they beat us to the market. You almost feel ready to quit? Okay, I've got one more slide. And phone was not an anomaly. Okay, the same thing happened to us in the tablet space. Okay, and I think what we did with tablet in terms of Windows RT and the experience stuff, amazing engineering against incredible odds and incredible challenges. Okay, and in fact, in order, Mr. Sinofsky and I have many disagreements. Okay, in fact, Mr. Sinofsky once sent email to my VP suggesting that I should be fired. Okay, are you saying you all agree with that? Badge of honor. Yeah, I'm sure I'm not the only one who had one of those. Okay, but he managed to produce a tablet operating system in an amazing amount of time, given the engineering system that we had to work with. Okay, and he did it by nearly killing the desktop. And you might say, why did he do that? That's insanity. Well, it's because it's the only way he could do it with the engineering system. It's just too hard to pivot the code. It's too hard to reuse pieces and put them together in different form factors in different ways other than they were in before. Okay. And again, positive network effect. Android and iPhone or iPad have killed us. Okay. The other one, I just have to call this out. This release, the 3.2.1 release of Android, that was the release. The major new feature in that release is they made it so your phone applications looked good on your tablet. Okay? We still haven't done that release. In fact, our story for RT and Windows 8 was screw you, phone. We're Windows. We don't have to share. Right? Let's be very clear. That was the story, and it was an engineering-driven decision. Okay? It was based around engineering technologies and engineering systems. It was just too hard to come together. Okay? And it was, and the management knew that they had to support not doing that in order to be able to produce what they wanted to be able to ship a product. Okay? All right. Everybody breathe a sigh of relief. We're going to move past that. Okay? There are other areas where we have similar problems because our code isn't in such a way that we can reuse it and repurpose it rapidly enough. Wireless routers. How many wireless routers run NT? 0, right? How many of them run Linux? All of them. Okay. Oh, yeah. You all know the answer. Smart TVs. How many of them run Windows NT? How many of them run Linux? Most of them. Okay. Wearables. I pity the poor guy who's got to try to figure out how to fit Windows into a wearable. Okay. In-flight entertainment. I hate flying on it's Delta now, but it was Northwest. I hate watching that penguin in the seat in front, in the screen on the back of the seat in front of me while Linux reboots because the dang thing isn't reliable. And I just think, oh gosh, why can't we just have NT there? Okay, in-dash navigation, we're in bad shape. We were in a great place, but we're actually in a bad place now with Ford, for example. Robotics. Okay, how many robots run NT? Not enough. Okay, network-connected sensors and devices, cloud appliances. I want to talk about cloud appliances just for a minute because in the cloud, where you have kind of this VM container thing, you really want to take your application and you want to bundle it with just the pieces of the operating system that you need and build something that's easily redeployable and reusable across many customers. And do you know how big a Windows VM is? And how long it takes to redeploy one of those and how painful it is? Okay? It's because the code doesn't work very well. Okay? Or it's not factored right. Anyway, but that's the place where I work. Okay, so why aren't we winning? Okay, actually. Yeah, okay. Well, I don't go back. Dave tells me, don't go back, whatever. All right. We're okay, we've been through the valley of desperation and despair, and now let's move forward. I want to make a couple of comments here. Okay, I don't want you to quit. I just want you to recognize reality for what it is, okay? And you might ask, well, I will assert this. You all knew all this. You knew things were not great in the phone space, and you knew things weren't great in the tablet space, and you probably knew that there are more Android phones and tablets than there are PCs in the world, okay? That we do not have a monopoly in anything anymore, okay? Other than a self-defined monopoly. We don't have an monopoly. And you knew that. But you're still here at Microsoft. And I'm still here at Microsoft. And the reason we are still here at Microsoft is because of the people in this room. We believe in the team. We have people we work with who we value and we cherish and we respect, and we know what they're capable of doing. And you know what the people in this room are capable of doing. And we believe that we can do better and that we can change the world still. And that is what we're going to do. And in trying to build a new engineering system, what we're trying to do is build an engineering system that's going to let you do that in the best possible way. Now, how we're going to do that as a business, I don't have any freaking clue. Okay? I'm not a business guy. I'm a researcher. I'm an operating systems computer scientist. I know what the technology has to do so that the business guys can make the right decisions and have the flexibility and the aggressiveness. Computing is going to change more in the next decade than it has in the last decade. It's going to go to more places, on more form factors, in more squirrely ways than you can imagine. And we have to make it reduce all the friction that we possibly can so that we can compete well. But we have a winning team. And that's why you're here still. And that's why you're not going to quit. You're going to go out and you're going to do better. Right? You're going to help your colleagues succeed. All right. Well, so why haven't we been winning? Our code's too entangled to be shared without forking. My worst example of this is the ribbon in Windows 7 had to be completely forked from Office. Those two code bases don't share anything. Not a thing. Because literally the only way the engineering system would let us bring code from Office into Windows was to fork it. And yeah, it needed to be refactored a little bit, but there was no way to push that refactoring back into the other thing. So you've been around Windows, you've heard about the big cycle. At least if you were here 7 years ago, you heard about the big cycle, 7 to 10 years. It's too entangled. We have isolated code islands that prohibit transparent interaction. Too much of what we do is tangled up in tribal knowledge. I go back to the example of I'm Neil Christensen in NTFS, and I change a line of code, and I build a new version of ntfs.sys. How many of you know how to get that into a VM and get it to run right? All right. Are you on that team? No. We were on that team. No. You're okay. All right. Okay. That is a bad thing. What that means is that no one else can say, oh, gosh, I got it, hit a bug. Let me go see if I can fix that bug. Let me go see if it runs all their quality tests, and let me push that change over to Neil's team so that they can take it. Okay? Or that thing in Outlook that drives you berserk. There's nothing you can do about it. Okay? Because we have so much that's in tribal knowledge. Dave and I have conversations. I remember a great WIPS conversation with Dave Probert about what the business of Microsoft is and what our value is. And he talked about productivity and stuff. And Dave's much more eloquent than I am. And I just put it as the value of Microsoft is we use software to make people's lives easier. Well, we need to do the same thing with the engineering system. We need to make people's lives easier. And getting rid of the tribal knowledge and moving these things that are, here's the script I run as a human that I understand, to here's the script that the machine runs, because it knows how to deploy NTFS, and it knows how to run the unit tests for NTFS. That's where we want to go. Productivity, there's this word called automation. We want to use it everywhere. Okay. Last one, we fork when we should merge. Okay, we just do it. Okay, every good engineer, when you see someone else's code, you look at it and you say, I could do this better than that. We all do, okay? Because engineering is about trade-offs. And your set of trade-offs and your experience leads you to want to optimize and change the code and produce it in a way different than the other engineer. Well, one of the things we all need to do is suppress that. What we need to do is channel and harness that. And rather than just forking the code, go figure out how to actually make the thing better and make it work together, right? And of course, we failed to adjust our rate of innovation because of the engineering systems. Oh, I didn't mention this. Are there any PMs in the room? Okay, all you PMs, close your ears for just a minute. I'm going to say something very offensive, and I don't want you to be offended because I like you. I spent a year as a group program manager back in 2003 when I worked in Windows Server. A good PM is worth their weight in gold. I truly believe that. The Windows planning process sucks. Okay? I don't know how in the heck we're going to compete with Android, who is shipping on a once a quarter cadence. And by the way, going back to the graph, which I can't go back to because Dave tells me I can't. The graph slowed down over the last couple of years. That's not because they stopped releasing or they slowed down their cadence. What happened is they figured out how to start shipping individual components without revving the entire platform. Their cadence has actually accelerated, okay? But you can't have a cadence of a quarter or faster when you have a planning process that takes 6 months, right? Scrum, folks, Agile, folks, okay? We got to change the way we work. So how will we know if we've made the right thing? Whenever I do a research project, I always ask myself, what are the acid tests? How do I know if I'm really succeeding, if what I'm, because what happens is all of us tend to do this. We have a problem, we come up with a technical solution, and we get excited about that technical solution, and we start going down the path and solving the challenges of the technical solution and everything else. And often, at least I don't know about you, I often lose track of what it was I was originally trying to accomplish. So whenever I do a project, I always say, what are my core acid tests that I can ask myself in the morning when I get up to tell me if I'm really doing the right thing and really going the right direction, or if I've gotten sidetracked. Okay, so the first one is, and ask yourself, can I find and list in the sources of any component of any product in the company without sending an email? Okay. The guys that work for me know I have a really good network within the company. I can always find somebody who can get us source access to whatever thing I want, because that's how I survive in research. But you shouldn't have to send email to do this, okay? You should be able to find it and list it and get it, okay? Can I change a line of code, build the component, verify that it passes all of the RI gates that the team that owns the component has, and flight it without sending an email? Wouldn't that be an awesome world, huh? Okay, second question. Can I archive my changes in a discoverable branch? So, I haven't got the other team to buy in, the owning team to buy into my change I made to their component yet, but can I put it someplace where I can get to it and anyone else at Microsoft who's interested in my potential change can look at as well? And then can I submit it for review to the maintainers and expect them to accept that? Now that last one, there's a cultural change that has to happen there. I'll give you that, okay? But it should be easy peasy to do all of that. And then the thing is, well then, go answer these questions again, but this time, say you're going to take that component and you're going to bring it into your product. And can you do all of those things in the context of your new product and how easily you can? Okay? If the answer to all those questions is, oh, piece of cake, we've built the right engineering system. And the answer is still what it is today because you all know what it is today. Then the answer is we haven't gotten the right place yet. Okay? And Apex, building one engineering system is a journey. Okay. Last thing I wanted, my quote, in an evolving world with accruing debt, and we've been accruing engineering and technical debt for many years, the most dangerous choice is the status quo. Okay. I have loved the discussions that have. Is everybody in the room on the InSysArc DL? Oh, some of you don't have full enough email boxes yet. Those of you who don't have your hands up, you should be on InSysArc. You'll have all the email you want. You'll know you're popular. The discussions on that DL, there's, by the way, over 2,000 people on the DL. It's fantastic, okay? And the fantastic thing about it is we've got people talking about, what could we do? How could we do better? And I can guarantee you whatever changes we're going to make in the engineering system to get to the end goal, there is going to be some piece of the engineering system you don't like. Okay? And you'll say, oh, why are we changing that? Let's not change the build language, or let's not change the source control system, or let's change whatever. Well, because and the answer I typically hear is there's too much risk for the business. Well, folks, the business is already risk. The most dangerous thing for us to do is to do nothing. Now, that said, what we're doing, I don't know that what we're doing is entirely right. And I'm hoping what we can do is produce the right engineering system that we can leverage the wisdom of the crowd to actually produce the right thing and get us on the right path. So what's Apex going to look like? Well, what is Apex? Okay, Apex is a combined effort between OSG, DevDiv, and Microsoft Research to incubate one engineering system that's going to merge both first-party and third-party tool efforts. And what we've got, if you look, it turns out we have a very large number of people across Microsoft whose job it is to think about engineering system. They're just isolated, and they produce separate engineering systems for every single product. And trying to bring that collective talent together and produce a single engineering system that is valuable for everybody, that's our goal. I'm sorry I've got stuff down the bottom of the slide. It makes it hard. Everybody has to crane their neck. Our North Star for Apex, particularly for the first system, is a new source componentization system. It's called Airstream, is the thing that we're modeling after. The concept's in Airstream. A new source code management strategy around using Git and VSO, Visual Studio Online. A new quality strategy around a concept of an inner loop, separating test and quality into an inner loop and an outer loop. I'll explain that in a few minutes. And a new build language and a new build system called Domino. And we'll make one comment. So there's a design note number 1, which some of you may have seen. And I guess what I said, design note 1 was intended to be a straw man. It's one of the things I do as a researcher is I put out a stake that is very aggressive and causes people to question it and question their understanding and what the space looks like, and it provokes discussion. And that's what EDN was intended to do. The other one is there's another design note. So whenever I run projects, I've done this for over 10 years now, I use a process called the design note process, which is what we try to do is capture our learning and our decisions in documents so that someone who comes along a year later or 2 years later or a week later can go look at the design notes and say, why does the system look this way? What are the things that I need to understand about the system, and why did they make these particular decisions? And that we try to put in the design note. And there's even a design note on how we do the design note process. So I encourage you to read EDN 0. And what it does is it creates a way that everyone can participate and we can leverage knowledge. And basically the thing is, you write a design note, and then you go to the architectural committee and you review the design note, and you get them to change what they're doing. If there's anything you don't like about the engineering system that we've talked about in Apex, or an idea that you think would be a better way to do things, I encourage you to write a design note and send me an email, and we'll schedule your design note review, and we'll bring it in, okay? All right, so let's talk about some of these things. So why a source componentization system? We've been working on componentizing Windows for a long time now, 10 years plus, and it's been slow progress. And I think one of the reasons it's a hypothesis I have is one of the reasons it's slow is because componentization isn't real for the developers. As you make change, there's no way for you to see what your experience should be around the source code, what it looks like as a component. So Airstream allows a first-class source-based component model. So you think about it as like when you actually go enlist, we want to change your enlistment model. You don't enlist in Windows. You enlist in a workflow, a work stream around a set of components that you're trying to work on. And maybe the component is Windows because you're the person responsible for building the Windows SKU. But maybe it isn't. You know, maybe you build your code goes into the kernel. And I use these diagrams of I have a component and it has facets, which are the interface between my component and my development efforts and other people. And some facets are around things like an SDK, so the libs and the .h files that are published for my component so that other people can link against it and take runtime dependencies. Other facets are like the runtime facet that declares the binaries that need to be in a SKU in order for it to contain my component, for example. And you start to build a machine processable description that has where the source code is, how to run the tests, what are the tests, how to package it into binaries, and how to associate analytics data with it. And some qualities of a good component. The way you want to think about this, we want to get to the point where we can liberate components from being in a tangled mess and that they can actually be produced on their own cadence. Okay? Case in point, core system, which is becoming now one core, okay, which is the most valuable component Microsoft actually has. It's the kernel and the file system and the networking stack and et cetera. It's used in Xbox. It's used in phone. It's used in Windows Client. It's used in Drawbridge. It's used in Azure. It's used in Bing. It's used all those sorts of places. We'd like to get to the point where that thing is built by itself. It has its own SDK. And people can take dependencies on it very easily instead of, in the case of the phone team in Phone 8 and Phone Blue, where they had nearly 50 people ingesting that component because it wasn't separated out by itself. Okay, and you can think about these components nesting. So like I have the NTOS kernel component. It's going to have build time dependencies, like for example, from the VC component. And it's going to produce, out of its runtime components are going to go into core system. And core system is going to go into a Windows SKU, for example. And you can imagine eventually us getting to the point where we actually start taking the individual components of the kernel, and, for example, and breaking them each into their own individual component that's separately buildable and testable and isolatable. Okay. This brings me one minor point. I just wanted to throw this out. Right now, we version everything. Okay, we're so tied up together. We version all the pieces of Windows together, with a few very rare exceptions. And what we want to actually get to the point is, so if the kernel was, if core system was on its own cadence, and say they produced a new version of core system, let's say once a month. You rolled up the latest changes and you ran it through the test and you produced a new version once a month. Now, obviously, you wouldn't want to ship a new kernel and a new core system once a month to customers out in the field. Okay? That would create a support nightmare. We'd have a new SKU we had to support for 10 years coming out every month. Okay, that would be bad. However, we do have a cloud business. And Azure and Autopilot and Bing, they would love to just pick up, they have to push service updates and things out every month anyway. They would love to pick up the new kernel every month. And if there was a file system change, rather than have to wait for a particular milestone, they'd love to just be able to pick that up. So there's reasons to do that. And you want to actually be able to talk about versioning these things separately as well. So there's a takeaway for you. The source controlled code management, I'm going to run out of time. Well, we do have. I do have till 1. At some point, I have to give you people time to ask me the scary questions that put me in fear. Okay. The source code management system. We have a system now that is based around very dense branches. We branch, particularly around in Windows, we branch the entire thing. And it's very hard for people to try out a new feature and share it with a couple of friends, for 2 or 3 people across different teams to come together and collaborate, because building branches is very expensive and supporting branches is very expensive. And the whole thing about trying to get to a system like Git is making the branching experience very easy, and making it so I can create a branch for every single bug, for example. So every work stream that I have where I have a different mental flow that is associated with a piece of work, I should be able to create a branch for and use it. Anyway, there's a bunch of Git goodness. If you don't know about Git and don't know why it's great, just ask one of your college hires. Okay? Find a college hire on your team and ask them. They'll tell you what's great about it. Okay? And if you say, well, that's great, but I'm still not sure we should move away from Source Depot, I'm not totally sure either. I'll say that right up front. I'm not totally sure. We're going to do some experimentation and we're going to learn. But this is the stake in the ground, a place where we say there's some really goodness there that we want to see if we can achieve. And maybe we can achieve it in Source Depot and not have to move to Git. And maybe we can get the VSO team to move Source Depot into the cloud for us. I don't know. We'll see what happens there. Okay, but there's some compelling opportunities there. Let me. Okay, and there's changes the way that we do the code flow and everything else. All right, I want to talk about tests because I think this one is really important. With Quality Day and the reorganization of the way we do. One of the key things here about thinking about tests and quality is this concept of loop. And the idea with the inner loop is I want to make it as a developer so that I have a set of tests associated with my component that when I RI, before I RI, I have a high expectation that my component's going to work for other people. Okay? And part of the value of the inner loop is creating a set of tests that are small and run fast and are easily maintained, that I can just have this very quick cycle of I make a change, I run my inner loop, I figure out what broke, I fix it, I keep rinse and repeat, instead of throw it over the wall to test and have them come back 3 days later and tell me that there's something broken. So trying to shrink that cycle as much. There's said unit test and functional test. The way they think about this in Bing is, in some of the teams, is they say your unit tests should run on the build machine in under 100 milliseconds. Okay. And that gives you some incredible agility. And we need to think about that. And one of the things, much of our test collateral is out the outer surface of Windows. Now, we have some teams where we have fantastic test collateral right around the component, but driving the change around that is a key thing that we want to try to do. And there's a great design note 17 that describes the basic concepts, and we're figuring out how to operationalize that as much as possible. And then the last thing I want to talk about is a build. Why do we need a new build language? And the reason we need a new build language is we need to change from where I think about, as a developer, when I interact with my code, instead of thinking about what are the dependencies that I have to know about in order to get this thing to build in some way, is how do I actually reason about what, when I add a line of code, or particularly when I add a line of code that calls a new API that I didn't call before, what is the ramification of that? How, if my code is used on phone, what just happened to phone SKU size? Did it just quadruple in SKU size because I chose an API that has a huge dependency set? Also, can I incrementally build that thing, and how does that work? And the build team, particularly, so Kieran's team and Joe Lynn's team have done amazing things with build.exe over the last 3 years. It is a completely different beast than it was 3 years ago, and it has amazing capabilities. And they have done it all the while fighting the build language, fighting sources, fighting DIRs. And we've got the point where to really accelerate the progress and the innovation, we've got to change the build language around that. And so we're going to do it. And do we have the right build language design right now? I don't know if we do or not. But we're going to try, and we want you people to look at it and try it out and see it. And the other thing is, when we say build, we have, in Windows, there's this concept of build and post-build. That's going away. Post-build becomes part of build. We actually want a build system that lets me express everything from how to get from I have a line of code to I have, let's say, a CBS component or a MSI or some other form, or a VHD that I can deploy and test. And that should be described with one build language. And the system should be able to reason about that and optimize and do incremental caching builds across that entire process. And the only way we can do that is to change the way we express our build. Oh, let's see. Oh, no, I've done the... I went back.
Oh, yeah, you did it.
Ah! Yes, I had one point. I'm sorry, Dave. It's a bad habit. The other thing, I did want to mention one thing. Particularly when I say do the full build and the post-build, think about right now how painful this is. Say like Windows RT. I would like to be able to type build at my desktop and say, I want to build a Windows RT VHD or WIM, okay, a Windows RT WIM. And it knows how to bring in the latest Office bits and the latest CLR and the latest Windows bits. And let's say we have an ARM64 version of that Windows RT, that it knows how to build both the 32-bit and the 64-bit components and bring it all together. That is tribal knowledge right now. It is total tribal knowledge, and we want all that to happen in one build. And the only way to do that is to change the build language and the build system. All right, So what should you do? What does the roadmap for Apex look like? We don't know yet. We really don't know yet. We're still trying to figure out how far we can do and how fast and what. There's some path of, we're going to adopt part of Domino, and we have to use a hybrid build where we're building some things with Domino language descriptions. Dave's got a question. Yes? Oh, that was the...
No. Okay, I did have a question.
Yes, Dave.
Just curious, final question. Are we using this to build and ship threshold starting in 6 weeks?
No. The question was, are we using this new engineering system to build and ship threshold starting in 3 weeks or 6 weeks? And the answer is no, not yet. Okay. What we're trying to figure out, there's a set of, this is kind of what this, there's a point, let's call it threshold plus 1 day, where we hope everyone is on the new engineering system across OSG. And unfortunately, that's a hard place to be, and there's a lot of engineering that has to happen in the engineering system before that. And so we're going to have to figure out how to bring incremental pieces in. Some teams will move faster than other teams. Some teams might move into the new source system faster than they move on to the new build language, which may be faster than they move into the new componentization system. And we're trying to, the answer of how you do that and what the roadmap looks like is going to be different for different teams, most likely. And we don't know how that all fits together. We're doing it, we have the best money minds can buy. No, the best minds money can buy. There, yeah. Actually, I don't know. Yeah, we do. We've got the best minds money can buy. I suspect there's more wisdom in this room than we have in those rooms, which is one of the reasons why we're trying to engage and create a very open process around the engineering system in order to tap into that. But we're trying to figure out how we're going to stage it and how we're going to roll it out. We don't know the answer to that. However, that doesn't mean that there's nothing you can do today. There are some things you can do today in thinking about this. And one of them is be part of the cultural change. Start to shift the way you think about your code. When you have a problem that you've got to solve, look for other solutions inside the company. See if there's some code you can get and make it work for your purpose already. In particular, instead of just looking at somebody else's solution and saying, that's not going to work for Windows, or that's not going to work in my case, say, how could I modify it so that it would work in my case? And how could I work with that other team so that how could we work together so that we could take their code and modify it so it works for my scenario and their scenario as well? Be part of the cultural change. And think about the other things. Go back and look at your code today. Think about how could I make my code easier for other people to use? And how might I make it easier for me to use other people's code in my system? Some other things, as we're trying to move to these components where we have reusable pieces that can be pulled into many different products, think about your dependencies. Are you using the right set of APIs? Is there a lower set of APIs that you might have? Could you refactor your code so that you had one binary that only used the low-level system set of APIs and another binary that used the shell APIs, for example, so that some of my value can be usable in platforms that don't have the Windows shell, but the rest of it adds value as I get the Windows shell. And about the headers, think about your headers. And the other thing you ought to think about is your build tools. The build tools is a cesspool of innovation. Okay? I can't remember, what is it, like 900 build tools, Nico? 800, I exaggerated. It's only 800 build tools in our build, okay? And I don't even want to talk about how many of them are Perl scripts. If it was up, I will say this, if it was up to me, I would go delete Perl from the Windows Depot this afternoon, okay? I only know one language, but anyway. I speak Southern Utah English, and that's all I can speak. Okay. The tools, we've created a bunch of tools, particularly the tools that we use in the post build that don't work very well in an item-potent build-type environment. And we're going to have to make some changes to things. So go back and look at the tools you're using in the build and say, gee, could I use something a little simpler to get my job done that might have less dependencies, for example? The other one is you're going to have to start, and we'll have guidance over the next couple of weeks. We're going to roll out some design notes that describe the carving process. In particular, we're going to start carving the code into components and segregating it. We are going to use a feature called subdepots, source depot subdepots. It's a great thing that was invented by the Xbox teams. And we're going to use that to start carving the code in, while it's still in source depot, into separate components of a granularity that supports the business needs and also has some benefits when we move to Git. And we'll have design notes that come out that describe how to use those tools and how to do carving. But now's the time to start thinking about, gee, is my code in the right places? And if I was going to move my code around in order to make it easier for other people to use my code, in order for the company to make more value out of my code, how might I do that? Okay, so ask that question. And then on the test side, prepare for the inner loop. There's a set of tools that we say, of recommendations of which tools you, but think, all of you developers have inherited a lot of test code, right? That you didn't have before. And you're like, what the heck am I going to do with this? Well, as you look at it, what the heck am I going to do with this? Ask yourself, which of these tests should go in the inner loop? Which ones can I make fast that are going to give me a high estimate of what the quality of my component is, particularly at its interfaces, the APIs, etc. And how do I separate those tests and get high reliability around those tests? In fact, we always want to refactor our code. Usually we want to refactor our code. Our motivation usually is around adding features or doing something in a better way. Think about the test way. A lot of the Bing has started reorganizing and refactoring their code around making it more testable and making it so that they can test it faster because it accelerates the inner loop of the developers in their productivity. All right, so there's a bunch of resources that are available to get you, if you want to know more, go to InchSys. That's the One Engineering Systems site. On that site, there's all of our design notes are in one section. There's a set of points of context. I wish we could invite 2,000 people into the room when we have a debate about a particular design note. Unfortunately, I can't figure out how to make that scale. Even if I use Link, I haven't figured out how to scale that. Okay? And so we have a set of representatives across the company, across divisions, who actually are the ones who come to the design notes reviews. And think of them, they're your U.S. senator. Okay? Only, unlike the U.S. senator, well, you might even be able to bribe them. I don't know. Okay? So, you can reach out to them, and as we announce a design coming up on a particular topic, reach out to your representative and say, hey, I think this needs to be changed. You need to go be my voice and make sure this happens. Okay? There is, of course, the InchSys DL that I mentioned, and I am the moderator of the design note process. If there's something you think screwed about the process itself, let me know, and I'll try to fix it. And then we have there's the DL, the InchSys Notes DL. If you don't want to receive 300 emails per day in your inbox from the InchSys Arc DL, you can subscribe to the InchSys Notes, and what you'll get is just the announcements of when we have a new design note and when the review is going to be on it, and afterwards when the final document's available.
There's also a digest.
There is a digest DL. Yeah, the digest DL. That is fantastic. I think the PM's done a great job with the digest. Anyway, it's exciting times. The wonderful thing about being in the bottom is there's no place but up. It's all opportunity. Okay? There's a lot of opportunity, and we have a chance to make Microsoft. We have fantastic people. We have a lot of money in the bank. And we have opportunity. As Steve used to say last year, a couple years or two, we're a fantastic startup. Okay? And let's embrace the change and go make a difference. Okay? Questions? No one has any questions. I knew it. I was perfectly clear. How am I even going to prioritize? Dave, do you want a traffic control?
Sure. Whoever has the microphone in their hand can ask a question. Here's the microphone. Who wants it first?
Yeah, that's good. That's good, Dave.
Let's start over here.
The plans to roll this out to the whole one Microsoft, not just OSG and DevDev?
So the plans for the entire company. I love the way Chris put this. When we had our first meeting with Brian Harry and Terry Myerson and Michael Fortin and Henry and everybody, there was some discussion. Well, like the Office guys, they're interested. Should we invite them in? And Chris said, let's only destroy 2 divisions of the company. Okay, in the case we get it wrong, let's only take down 2 divisions of the company. The answer is, what we see is a year from now, when we've kind of got things ready to deploy across really broadly into deployment in OSG, that we would start adding in other teams and bringing them in. Now, we have invited them to have representatives in our architecture discussions so that as we make decisions, we're not boxing ourselves in a corner.
I noticed on one of your slides.
It says it's, oh, there we go.
There we go.
I noticed on one of your slides that it said something about early adopters not in box being able to get on early. And the fundamentals team has a bunch of service side components that we host internally, and we want to get onboarded. Who do we contact to actually get in the loop for that, to get ourselves set up for being able to take advantage of at least some of these things, so we can start converging some of the tech there together instead of building in separate isolation?
Reach out to David Lemson's team, PM
Lemson.
work. Okay, that's going to be my suggestion there.
Thanks.
Oh, by the way, if you're out on the fringe and you really want to ask a question, come up here where you're closer to David. He'll have to give you the mic sooner. Go ahead.
So in the beginning of the talk, you talked about tools and process that actually sort of comprise Apex. So, with all this data, I mean, it's so confusing to figure out what's the current state of Apex. Is there any dashboard where, you can say that, look, this is the build system, this is the unit test, this is how the testing happens, this is how telemetry is collected, and these are the tools and processes that we think are, as of today's Apex.
Yeah.
And this is the roadmap for the future, so that we can work with our teams and there's no confusion as to, hey, do I use Git, do I use Source Depot, do I use Atlas, or do I use something else?
Well, so the easiest, so
a sort of a catalog.
We don't have a dashboard. The closest thing we have to it right now, and there's probably room for improvement on our PM side on this, but the closest place right now is go to the design notes section of the website, the SharePoint, because the design notes section has both the design notes that are currently active, the things that we have had meetings about and agreed upon. It also has the things that are drafts, concepts that people are thinking about, and they're marked as which they are. There's also, it shows on there when they're being reviewed and where they are, so you can actually get a pretty good view of how disorganized we truly are at the moment there, okay, and see progress as it comes together. Who has the mic now?
Does the build system support building for Android, Linux, iOS?
The build system right now doesn't do cross-platform, but it's in their ambitions. I'll put it that way. Nico's nodding ahead. Yeah.
What I'm saying is it's really a foundation for customizing the build system for whatever you want. And we're trying not to, as you said,
Yeah. So Nico's response is they're trying to build a very flexible build system, that there are ways that you can bring it. It's very flexible for you to bring in the tools to support additional platforms or things. Okay, who has the mic now?
Have you looked at a lot of problems you're trying to solve as actually cultural problems rather than technical? Let's say access to source control is explicitly, Sinovsky plus kind of everybody trying to keep IP value.
Yeah,
and the same for testing. It's not the technology problem, or you can try to fix it, patch it through technology, but it's more like a cultural / political issues.
So you know what? Most of our challenges are cultural, and one of the things I'll say is the executives have really gotten the memo about One Microsoft. I don't know if any of you noticed. I trying to remember what the DL or what the URL is. The source control policy for OSG has changed. As of a couple of days ago, basically, if you are in an engineering group anywhere in Microsoft, you can have access to the Windows source code, and you get read-only access without even asking for it. And if you want read-write access, then there's a RamWeb group that you go to. And the fun thing of this, you don't even have to be approved by anybody in Windows. You just have to be approved by an L68 somewhere up in your chain. Okay? DevDiv is starting to do this across the company. People are embracing that particular piece of the cultural change. There's a lot of other cultural change that's going to have to happen. Be part of the cultural change, right? If people know that this is what you want to do, well. The other thing I'll say this is, yes, it's mostly cultural change, but the tools make it either hard. A particular culture is either easy or hard, depending on what your tools are. And that's why we're changing the actual engineering, the tools portion of it. All right, who's got the mic now?
I do. So in reading all of the documents and being on all the threads and reading all the threads, and I believe I've made a couple of responses on those, what I've noticed is we don't have the folks with the deep subject matter experts from the build engineering discipline themselves or operations at the table, at the design table. And the reason this concerns me, and I'd like you to address it here, is Boeing, for example, tried designing one of their airplanes one time without the assembly crew at the table.
Yes.
And they ended up with attachments inside of bulkheads where you couldn't get a wrench on it, right?
Yeah.
My concern here is without the folks that have lived the pain of the engineering system and keeping it up and running all these years, knowing what all the gotchas and end-to-end insertion and telemetry they need in real time to be proactive about things.
Right.
If this is not in the design, it's certainly going to be too expensive to put in after it's finished.
Yeah.
And my goal, long time here, as a build engineer, design person, is to have a lovely consolidated automated system that self-heals and is fast and smart. But if you don't have the telemetry baked in, you can't monitor in real time to see where it might be failing and might need to be fixed in real time. So could you address this?
So the answer is, if we don't have the right experts in the room, we want them in the room. Okay. In terms of the build tools, we have John Lynn's team is involved, Kiran Doraiswamy's is involved, right? So, but if there are other people that you're saying, oh, so-and-so really should be involved because they have this deep knowledge, let us know, okay? And if you have to, send me email, okay? Because we want them involved. Okay, Mike?
My main barrier to reusing code internally is documentation. Why have you mentioned it at all? I had to track down an individual engineer that wrote an API in order to use it recently.
Well,
he wrote a series of responses that no one else will ever read.
I have mixed feelings about this one. What I have found from my experience is the best documentation is unit tests that describe exactly how you should interact with this piece of code and demonstrate how it should be used in as short a way as possible. That tends to be the most effective documentation I see. But that's a good point. I don't know. We haven't done anything about that, and we probably should. Thank you for raising it.
Hands? Last question.
It's going back to like current build. Like, are you using data from current build system to actually drive some of the decisions? For example, source depot Git. I like both, but right now, at least based on my interactions with it, none of the things which you listed is actually a pain point. And so when I see these discussions where like 100 man hours, like people discussing moving to Git versus actually making a better build, it's like, well, where is the data? Like, where is the data which proves that like solving source control is necessity?
Well, you would just ask you asked two separate questions, okay? One of them is, are we using data? Okay, and are we trying to get data? And the answer is yes, and yes, and we probably, even if you want to reach out to like the design note author of a particular thing, you could ask them, what data did you use? What do you have available? The other comment I will make is, Dave Cutler sent me email. Always a fun experience. Actually, I love Dave. I was surprised he actually acknowledged me finally. No, that's not fair. Dave and I worked, when I joined Azure to work on Drawbridge, Dave was there and had a great interaction with him. But Dave sent me an email and he said, what's your data to prove that we need a new build system? Or a new engineering system, excuse me, a new engineering system. I already showed it to you. It's those 4 slides, okay? We can have debates about which part of the engineering system is most effective to be changed for things. But, and I'm very open to those, and I think we should have them, and they're healthy discussions. And I've loved, I'll put it away, one of the things I have really valued myself is the input I've gotten from people saying, you know what, instead of doing these 3 things you're doing, how about we did these other 7 things instead? Those have been very, very valuable because they've pointed out things that, and we're looking at, you know, where should we prioritize? Where should we put additional people? But we clearly have to do something about our engineering system. It is driving, it has put us in the place where we are right now. Yes, there have been some leadership mistakes. You know, I going back to the phone data. The fact that we didn't do iPhone, that was a leadership failing, okay? But you know, Microsoft has never been a fantastic first leader in a new market. We get in early, and then we stop growing, and we stop learning, and then we get blown away whenever we're first leader. It's inevitably what happens. But we've always been a fantastic first follower until the market started moving too fast for our engineering system. Phone and tablet and those other areas that I listed, those are the ones where we just haven't been able to move fast enough. And the data is right there, and you can't refute it. I will say that. Anyway, thank you for coming, and please keep the feedback coming.